Okay guys, in this video we're going to cover 13.5 solution concentrations. And so what is a concentration? Concentration of a solution. Concentration is generally expressed as a ratio of the amount of a solute over the amount of the solvent, or the amount of solute per amount of the solution. And the difference here between the two, of course, the solution is made up of the solute and the solvent. Okay, now we're gonna move, fast forward to molarity now, because as per the syllabus 13.6, now 13.6, let me see, 13.7 is skipped in our syllabus. So what I'm going to do here is I'm going to go straight into molarity concentration unit. And the molarity, so I'm going straight to 13.8. And so in the molarity concentration unit is nothing else is the M is equal to N over V, where N is the number of moles of the solute, and the V here is the volume of solution here. And remember guys, solution is made up of the solute and the solvent. And also the volume must be in liters. Just remember guys, liters here is very important. Okay, so what kind of problems we could get here now? And so what I'm going to do, guys, I'm going to solve several problems here on this concept. And the first problem is 13.9. So they are giving us different here, A and B. So what I'm going to do is I'm going to solve both of these problems. So in the first problem, we are given moles. And so the problem will be 13.9, this is page 581. So the first problem will give us 1.54 moles here of KCl. And then they give us volume here, 875 ml of the solution. And again, guys, remember milliliters, you must convert into liters always when you do these calculations to obtain the molarity of the solution. And what they're asking us to find is to determine the molarity. And the molarity, of course, I already gave you guys the formula, is M is equal to N over V. So M will be now equal to the 1.45 moles over 0.875 liters. And again, I'm just on the fly, I just converted the milliliters into liters. So I need my calculator now. Let me get my calculator to do this operation here. Okay, so I got 1.45 divided by 0.875. And so what I got here is the final answer. So again, this is three significant figures, then my final answer must be 1.66 molar. And that will be my final answer for this problem. So this was problem A here. What happens now if I go and now do problem B, see what the difference between the two problems. And again, this one was straightforward, just plug into the formula. All right, let's go and see the next one. So the next one is a little more complicated, but nothing special here. So what I'm given here is a mass. Mass is given, guys, is 57.2 grams in here of ammonium bromide, and it's dissolved in enough water to give 2.6. So now here they're giving us liters, so I do not have to do any conversions here. And again, what I need to find out is I need to find out the molarity. Now, this problem can be solved several ways. Now, one of the ways we can just use two formulas. Molar mass is equal to ratio between the mass of the substance over its number of moles. And then the molarity is equal to N over V. So you can find from this formula now, you can state now that the N is equal to, from this formula, is equal to M over the molar mass. So once you do this, you can plug this number in here and you can solve, guys, for the molarity here. So let's do it this way, and then we'll do it a different way. We'll do it through conversions. Okay. So again, the first step, we need to find number of moles of ammonium bromide. So that would be now, let me just, before I do this problem, so when I need to find number of moles now, I have to, it's a ratio between the mass, which is this number right here, over the molar mass of this ammonium bromide. So how do I find molar mass? Now, let me just separate these two problems. So the ammonium bromide is made of the three different elements. So I got 1 mole here of nitrogen, 4 moles of hydrogen, and 1 mole of bromine. So let me get those molar masses. So this is 14.01 grams. This is 4 times 1.008 grams. And this 1 mole is 79 point, you know what, let me just move everything here. It just kind of gets here a little bit too close. So let me just solve it. Let me just solve the molar mass in here. So I got, again, 1 mole of nitrogen, which is 14.01 grams. I got 4 moles of hydrogen, 4 times 1.008 grams. And I got 1 mole of bromine, actually bromide in this case. And that would be now 79. I'm going to check it with the periodic table, 79.90 grams. All right, let me just check it real quick. So bromine, 79.90. Yes, 79.90. Okay, all I have to do now, add them all up. I'm going to add them all up. I'm going to get my molar mass here. So that would be 4 times 1.008 plus 14.01, and then plus 79.90. So I got my molar mass here, 97.94 grams per mole. So that's my molar mass in here. Okay. So I can right away, I can just plug it in now here. So the mass here is 57.2 grams of ammonium bromide divided by 97.94 grams per mole. And again, this is the same substance here, NH4Br. Grams and grams cancel out. So what I'm going to get here is I'm going to get now number of moles. Almost solved the problem, guys. 57.2 grams divided by 97.94. And so I got here I got 3 significant figures, 5, 8, 4, and I got a little 0 here. Always like to carry extra digit. And that will be now moles of NH4Br. Okay, so my next step will be to find the molarity. And the molarity will be now the ratio between the number of moles and the volume of total solution here. Number of moles of the solute. So let me just put number of moles of the solute I just found in here. Moles divided by total volume, which is 2.15 liters. And that will give us, here I'm going to bring in here, the final answer, which is now 3 significant figures here, and it will be 0.272 molar. Okay, so this is one way. Now, one way to solve this problem. Now, what's another way, guys, to solve this problem now? Okay, so another way you can just convert. So I got my molar mass in here. So let me just erase this to give you a little space. All right. So I can just solve it, you know, pretty much everything here in just converting. All right. So how do I convert now with the information given? How do I get now to the final molarity answer? All right. So let's figure it out. Again, I'm going to use the same formula for molarity here. All I need to find just the number of moles because I have the volume, and just plug in and I pretty much solve the problem. Okay. So number of moles of ammonium bromide is equal to, I'm given 57.2 grams of NH4Br times, I'm going to convert into the mole, 1 mole of NH4Br, and I will divide it by the molar mass, 94 grams of NH4Br. Okay, so let me get that answer. So, oh, by the way, I mean, it's obviously what I'm going to get here because this will be divided by this, and that's what I will get now, number of moles. And then my next move, as I already explained before, all I have to do is just take the number of moles here, plug it in this equation over the volume, and I'm going to get, guys, now the same answer. Okay? Now, I'm going to now solve some more problems here in 13.8. So let me see what other problems here are presented. All right. So let's get those problems solved. Okay, so I'm going to move now to the next problem. Just again, follow me in the chapter. All right, so my next problem here will be 13.10 on page 583. Okay, so let's see what's given here. So I'm given here a citric acid, C6H8O7, and it is a substance that gives lemon juice and other citrus fruit juices a sour taste. How many grams of citric acid are present? So they're giving me here the volume of 125 ml. They're giving me here molarity, 0.400 molar. And they want me to use now, they want me to find the how many grams of citric acid present. So they want me to use here amount of the solute using molarity as a conversion factor. Okay, so let's do it. So we need to find the mass of the citric acid. Let me just make sure I got everything I need here. All right, so let's do it. Okay, so I'm going to start with what's given here. I'm given here a volume, and I need to find the mass. So the mass will be equal to, I'm going to start with what's given, 125 ml of citric acid. Multiplied. So I need to use this as a conversion factor. This could be, this molarity could be just this term expanded into the moles over 1 liter, or you don't have to put 1, just put liter. Well, and that will be your, well, actually here 1 will be kind of important because we want to express this as a conversion factor. And so once you got the units in the numerator, denominator, that's your conversion factor right there. But I cannot use conversion factor yet because here I got milliliters and here I got liters. So I have to convert these milliliters here into liters. So I'm going to say 1 liter contains 1000 ml, cancel. And now I can convert this into the moles because 1 liter of this solution is equivalent to 0.400 moles of citric acid. I don't have space in here, so I'm going to write it in here on top. But it belongs to this. Times, all I have to do, guys, now is to get the grams. So I'm going to say now 1 mole of citric acid. And I have to find, guys, the molar mass of citric acid. And you know how to find the molar mass. All you have to do is just take the mass of carbon from the periodic table, multiply it 6 by 6, take the molar mass of hydrogen in the periodic table, multiply it by 8, and take the molar mass of oxygen and multiply it by 7. So when I do all of that and add them all up, I get 192.14 grams of citric acid. So when I do all of these calculations now, I should get the correct answer. Again, I have three significant figures here. 125 divided by 1000 here, multiplied by 0.4, and multiplied by 192.14. And so my final answer, three significant figures, will be 9.61 grams of citric acid. Okay, and that will be the final answer. So again, 13.10, page 583. This is how you would solve this problem here, guys. And there are, if I flip the pages here, there are other problems here. And so we'll get to those in the next video.